When mankind first started sending spacecraft out to explore the solar system, the first planet to be visited was Venus, our closest neighbour, in 1962. Next was Mars in 1965, and then Jupiter in 1973. Only then came Mercury in 1974, and already this order might seem a little odd. The closest distance between Earth and Mercury is 77 million kilometers. In fact, it is the closest planet to us on average. The closest distance between Earth and Jupiter is 588 million kilometers, almost 8 times that. And Jupiter was visited again in 1974, twice in 1979, in 1992, in 1995, in 2000, in 2007. Multiple missions were launched to Saturn, Uranus, Neptune, to comets and asteroids, while Mercury got nothing for 30 years. Is this because it was deemed uninteresting? Did we discover everything there was to discover about it with that single first mission? No. The first mission was a flyby and only mapped about 40 to 45% of Mercury's surface. Actually, the real reason is that Mercury is one of the most challenging planets to visit in our entire solar system. Why? Well, Mercury exists in a furnace. Due to its proximity to the Sun, its surface temperature reaches highs of 430 degrees Celsius, so any probe visiting it would need to be highly heat resistant. But that same proximity to the Sun means that any probe launched towards it will accelerate faster and faster due to the immense gravitational pull from our star. Using rocket fuel against that would be like swimming up whitewater rapids. Combating the Sun's gravity required too much fuel for a Discovery-class spacecraft to carry. Slowing down the spacecraft enough to be caught up in Mercury's orbit seemed impossible. But all that changed with the Messenger mission. I'm Alex McColgan and you're watching Astrum. And today we will be learning about mankind's first and only attempt to place a probe into orbit around one of the hardest to reach planets in the solar system. Weight is a challenging limitation when it comes to spacecraft. The heavier a craft, the larger a rocket needed to get it out of Earth's orbit, and the more expensive everything becomes. Scientists try to keep everything as light as possible to reduce this cost. As fuel takes up precious weight allocations that could go towards scientific instruments, scientists try to only take what is necessary to help them complete their journey. However, for about 30 years, scientists could think of no way to put enough fuel on a probe to get it to slow down enough to enter Mercury's orbit, especially if they wanted scientific equipment on board too. So, after the success of Marina 10's flyby missions of Mercury in 1974 to 1975, Mercury exploration was put on hold. But in 1985, an orbital mechanics expert named Chen Wanyan realized that there was a way of getting a probe into orbit around Mercury that didn't need new technology. Instead, he had worked out a particular route an orbiter could take around the solar system that would slow it down enough to enter Mercury's orbit with only a few course corrections. Rather than going straight to Mercury, the orbiter would need to go a longer way. How long? Under Chen Wanyan's model, a craft would orbit the Sun about 15 times, flying past the Earth once, Venus twice, and Mercury 3 times before finally slowing down enough to enter its orbit on the 4th pass. All these planetary flybys would be essential. By skimming the planet's atmospheres, vital speed could be shaved off from atmospheric drag and due to the gravity of the planets. The entire route would cover a mammoth 7.9 billion kilometers and would take 6.5 years. Chen Wanyan's findings were not immediately picked up, but in 1998 NASA began to take an interest in the idea, and after seeing the feasibility of the route, they launched the Messenger probe in 2004. Messenger, or the Mercury Surface, Space Environment, Geochemistry and Ranging Probe, was only about 1.8 meters long and 1.3 meters wide, and weighed 1,100 kilograms. This is small and light for a typical NASA mission. Just a comparison, Juno is 20 meters long. Messenger came equipped with a powerful thruster, a ceramic heat shield to protect it from the sun, 2 solar panels, and a whole suite of scientific equipment for imaging and measuring data from Mercury. Scientists hoped to take advantage of this opportunity to learn as much as they could about the chemical composition of Mercury's surface, its geological history, its magnetic field, and its core, among other things. Messenger spent its first year in space making 1 orbit around the Sun before meeting back up again with Earth. This gave scientists a chance to test its equipment on a known astronomical body, to make sure there weren't any errors and to make any adjustments as needed. Messenger took some photos of Earth and the Moon, and also tested its other equipment to take readings of our atmosphere and magnetosphere. Fortunately, everything was working perfectly. As it began to head further sunward, Messenger employed a clever technique to help reduce its acceleration towards the Sun. It used its solar panels to catch solar radiation, like sails on a ship might catch wind. Solar radiation hitting an object actually pushes it very slightly. While this force is very tiny, because Messenger's journey was so long, it really added up. Making the most of this phenomenon was one of the ways Messenger saved propellant and decelerated naturally. The next notable landmark in Messenger's journey came in 2006, when it did its first flyby of Venus. Sadly for scientists, this moment came at a time when Venus was exactly on the opposite side of the Sun from Earth, which meant Messenger was not in radio contact. It did take some photos of the planet which it later sent, but otherwise it performed no science. However, in 2007 it passed Venus again. At that time, another spacecraft was orbiting Venus, ESA's Venus Express. Messenger and the Venus Express took the opportunity to work together, performing the first ever simultaneous measurements of particle and field characteristics of the planet. But then it was on to the main event, Mercury. Messenger made its first flyby of Mercury on the 14th of January 2008, with everything going smoothly. The same was true of the second flyby. But during the third flyby in 2009, something went wrong. Messenger went into safe mode, which was designed to protect systems on the craft in the event of an error. How disappointing to have come so far, only for the mission to potentially fail during one of the final stages. Messenger remained in safe mode for what must have been 7 hours of stress for all the scientists involved. You see, Messenger had to pass through Mercury's shadow during this flyby, meaning it had to rely on its batteries for 18 minutes. Something wasn't configured right in the power management part of the software. Fortunately, Messenger's computer reset once power from the panels charged the battery, and it was able to continue with its mission, swinging around the Sun one more time before finally entering orbit around Mercury on the 11th of March 2011. Messenger took up an elliptical orbit around Mercury, alternating between as close as 200 kilometers and as far away as 15,000 kilometers. This is because Mercury acts sort of like a giant sun mirror, radiating heat back into space. Remaining too close to Mercury was too hot for Messenger, even with its heat shield, which was more designed to protect it from the Sun, 7 times brighter by Mercury than it is on Earth. So moving further away every 12 hours gave it a chance to cool off. Messenger spent the next 4 years in Mercury's orbit, far exceeding scientists' hopes and expectations for the mission, as they had originally planned for it to only last 1 year. Before launch, scientists had hoped that Messenger would take at least 1,000 photos over the course of its lifetime. However, Messenger took over 200,000 photographs, giving us a complete map of Mercury's surface in high resolution and color, as well as photographing nearby comets and other planets. On the 25th of December 2014, Messenger's propellant, so carefully saved up until that point, was finally about to run out. By this point, Messenger was orbiting a mere 25 kilometers from the surface of the planet. Scientists gave the thrusters one last burst to extend its orbit for as long as possible, but on the 30th of April 2015, Messenger crashed into the surface of Mercury. After a journey that had lasted over a decade and had covered literally billions of kilometers, Messenger's journey had come to an end. Now, if the science findings of this mission would be something you would be interested in for a future video, please let me know by commenting or leaving a like. I definitely think it's an interesting topic, and I hope you will too. And the adventures around Mercury don't end with Messenger. In 2025, the ESA-JAXA joint Bepi-Colombo mission will arrive at Mercury, taking over the reins from NASA. So if you want to know more about this mission before I end up doing a video on it, there's a great documentary on Magellan TV's streaming platform called Mercury or Bust, which goes into detail about what makes this mission special and what ESA and JAXA hope to achieve while there. They claim the Bepi-Colombo mission is one of the most complex scientific missions ever launched, a single spacecraft that will split into 2 spacecraft upon arrival at Mercury. So it's definitely worth learning more about, and with my link in the description you can watch it for free, because you'll get a 1-month free trial of Magellan TV's entire catalogue of over 3,000 science documentaries. Thanks for watching. I hope you found value in this video. If you did, liking the video, sharing and subscribing really go a long way to helping me make more videos like these in the future. A big thanks as well to my patrons and members who support the channel too. If you would like your name added to this list, check the links in the description. All the best and see you next time.